And welcome to the series Technologies Now Black Magic, and specifically we're going to talk about Git, uh, and so is the title. So without further ado, let's see what's a black magic type inside Git, but in actual it's not. Specifically, we're going to talk about merge conflict. So what I've envisioned is that we write code when we are working alone or when we are working in a team setting. So when we are working alone, it could be for a personal initiative, it could be a side project, it could be a school or a university project. Uh, or if you're working in a team setting, it could be for some project in our company, or it could be some distributed open source work like Linux or some library of your language, or it could be something of that sort. Quickly, first things first. So there are some of the things that you should make yourself aware of. Now, I wouldn't say it would be a deal breaker if one doesn't know them, but it would be great if you know these things, as it just helps significantly to reason about things should there be any questions arising while you're trying to follow. And by no means their application is to be closely or even fairly limited to the subject of this video. That said, let's just quickly go over these items that you would want to roughly know about. So I assume you already read all these things. Now I'm just going to highlight some of the things which are more closely related than the other. So you want to really be sure about what is a fail close approach, what is the set data structure, what is the sequence diagram, what's the meaning of precision in terms of computer programming, what does it even mean by content tracker Git, what is a branch diversion, because that's actually pretty critical to this video in specific. What's a hash? So you might have seen the symbol hash or a pound symbol, but that's not the hash which Git typically talks about. It's a random looking word, for example an alphanumeric string like A1, B2, C3 and so on. So we want to be sure that we know at least these things in order to better follow the video. Writing code alone. So the workflow when we write code alone is going to look something like this. So you're seeing that. I hope you can see the zoom. There are four entities here: myself today, which is me in today point in time; device one, which is a device, let's say my MacBook, in my possession, and there is no shared ownership, just for keeping everything sane; myself today plus one, which is tomorrow; today plus two, which is a day after tomorrow. When we are talking in terms of Git, we have to do something known as Git repository initialization. So we do that as soon as that intent is shared by us to the appropriate program inside a device. That program is going to process that request, and internally, upon receiving a green signal, that program is now going to return the signal to us. But we want to still verify whether the thing has been created or not. So we are going to give another command to see if the repository was successfully initialized or created. When that request is received by some appropriate program inside a machine, is going to take that request, is going to process it. Internally, it is going to receive a green signal for that request, and it is going to forward the same to us. And once we are happy with that, we're going to write some actual computer code, and we are going to write it on our machine, which would be on some program. And once we save that code, the save intent is going to be received and processed by the program. It's going to, after receiving an internal green signal, return that back to us, and we can read the output. Let's say as a follow-up to that, we want to save this work in a Git repository. So before we can do the actual save, you want to prepare your machine, prepare your code for that. So in the preparation step, you're going to do something like this, where upon receiving the intent, the program is going to do some internal evaluations. That's going to be passed, and a green signal would be internally received, and an appropriate response would be returned. Now, while doing the actual saving to the Git repository, we are going to do that, but at the same time, we are going to also push our code to GitHub. So this is what we would do if we don't want our code to just live on our machine. And for some reason, if a machine dies or if we lose access to it, we wouldn't be able to get back to our code. But if it's on GitHub, because it's hosted on the cloud, it's accessible on github.com, and you can simply get to it whenever you want. So when you do that, the intent is received by an appropriate program on your machine, and that is going to be evaluated, and an internal green signal is going to be received, and you will receive a successful response back. But let's say on a day after tomorrow, which you see is this line, just to be sure you can see that, you just realized on your dinner table that, hey, I actually forgot to make a quick change. So since my code lives on GitHub, let's just go there and make the change. You went there, you made the change was evaluated, whether it's conflicting or it's a problematic change, it's all good. GitHub was able to internally evaluate and found that there is a green signal, and it returned back the result to you that it's all good. And now you also know that, well, my local code is actually not up to date, so I'm going to fetch the latest results from GitHub, so that next time I want to work against, I am going to work against that piece of code. But the word fetch here is important because it plays a role in the Git nomenclature, and Git has something known as Git fetch, and that's what we're talking about here. So when you do a fetch from GitHub, the intent is received and a green signal is internally received, and it is going to send back a successful response with any appropriate data it has to return. Now you are writing that some more code, and that some more code is now being written, which is an entirely new code. It has nothing to do with the old code. You're just writing that code today point in time, and you save the code. The code is internally evaluated, it is saved, and a response is successfully received. So as you can see, when you do a preparing to push to the Git repository, which is a pre-step before you can actually push to the Git repository, some Git internal calculations happen. Upon that internal calculation, there is a red signal. That means Git actually failed to figure out a sane path of executing the intent which you shared, and that's because you have something known as a merge conflict. So we will go into the exact detail as to what could have happened, and that's actually a next step, which is glimpse of a merge conflict. So in a merge conflict, something like this would have happened. So myself today on machine 1, I said for file 1 that line 1 should say hi, and I eventually want that code to live on GitHub. So let me just fast track and directly save everything on GitHub. So what's actually happening here is that you're writing the code locally, you're saving it in the local Git repository, and then you are uploading that Git repository on GitHub. So all that thing is happening when I say line 1 should say hi on GitHub. And finally you receive a successful signal. So you know now that your code on GitHub for file 1 on line 1 says hi. A day after today, which is tomorrow, you want to make a change directly in GitHub, and you want the line 1 of file 1 to instead say hi ... So previously it just said hi. So now we know that the remote code which is living on GitHub is actually different than the code which is living on our machine, and the change was successfully accepted, and a successful result was returned. Now a day after tomorrow, which is a day after tomorrow, well, you probably know that what's gonna happen is that on our local machine we are going to change the line hi to say hello, and when we are trying to push this change in GitHub, something interesting happens. We are not able to actually do that, and rather we received a failed signal, and the reason for that is merge conflict has arisen. So a merge conflict is a condition which happens when the local copy against which you are working is unaware of the change that has been made on the remote. So a remote in this case just happens to be GitHub, but it can be any other platform for that matter. So what we are trying to do is we want hi to become hello, and we want to make this change, but GitHub knows that the file is not hi, it is hi dot dot dot. So when you say that I'm changing my hi to hello, GitHub says that wait, I don't know what you're talking about because I know about hi dot 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 and not hi. So I don't know where this thing is coming from, so I'm not going to merge this safely, and I'm just going to not do anything about it. So GitHub ends up taking a fail close approach. That means when there is a confusion, don't move ahead and take a decision, rather leave the decision to some other party. That some other party is the owner, and that's us in this case. So you know exactly that why merge conflict occurred. That's because making the change of hi to hello is not a safe one, because if you do that you would end up losing the progress, which is hi dot dot dot, and maybe you're not interested in doing that, and you just it just happens to be that you hit this condition because you forgot to work against a code base which is hi dot dot dot. So locally, if you make sure that you're working against an up-to-date code, that is the local file is saying hi dot 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 and not hi, it would be absolutely fine to make this change. uh, Going to the next part, that's writing code in a team setting. Interestingly enough, writing code in a team setting is not a lot different than writing code alone when we think about this sequence diagram. Uh, on myself today plus 2, which is a day after tomorrow, you see that there's a note here which is called sprinkling some realisticity. So let's say that sprinkling some realisticity is actually some other person from your team who is working, and he actually was able to successfully follow the standard procedure, and he pushed the code on GitHub. And now your local copy is actually old, and you are making changes to an old copy. And when Git actually sees this intent, it's not going to be able to do the merge for you, because there is no sane path to do that. Whether I should accept the change which you have and reject the which your teammate has made, or vice versa, it's a decision which can only be taken by you, and that's why I would take a fail close approach and I would say that a merge conflict has occurred. It is as easy to solve this as it is you probably know how it looks. So other than that, I think if you think about Git, all it is doing is pointing into specific commits in your code. So if you are pushing your change to a Git repository, and if that change has a particular ID associated with it, you can at any point in time make your Git to point to some other ID, and that would simply make your code uh, get over with this merge conflict which has arisen. So that's all from my side, and if you have any suggestions, you can definitely reach out to me, or if you want me to go over in the detail of something specific, please don't hesitate. And that's all from my side. Thank you.